Okay, we're continuing with the review for sections 7.1 through 7.6, and this is problems 20 through 23. All right, in this first example, number 20, we have what look like radicals with different radicands. There's a root 12 and a root 48 in the first problem, and you would be tempted maybe to think that these can't combine. But the issue here is that these aren't simplified, so we will first of all break apart the root 12 and the root 48. I'm going to do something a little unusual here and just work down one side of the problem next. So you can see I've done the left-hand side there, simplifying the square root of 4 to 2, and then taking care of the negative 3 times 2. And then we catch the other side up, and the square root of 16 simplifies to 4 is the central part of that one. And once we get all the way down here, you see that these really are like radicals, square root of 3 and square root of 3 in each, so they can combine, and you get 14 root 3 for your final answer. The next one is just the same skills, but you have to work with perfect cubes. So 4 is not big enough to have a perfect cube hidden in it. We're not going to mess with that. But that 32, cube root of 32 has an 8 hidden in it. So I'm going to break apart the cube root, I keep saying square root, cube root of 32 into cube root 8, cube root 4. The middle number simplifies to 2. And then we simplify that to 4 cube root of 4 at the back. Add to it the other one in the front, and you get your answer of 5 cube root of 4. Okay, on the next one here, we have conjugates. And when you're multiplying conjugates, let me first of all highlight what makes these conjugates. They're identical except for the sign of the part that has the cube root or the root in it. So positive and negative 3 root 2 are the features that make these conjugates. The other part, the 5 in front of the binomial, has to match. So one part matches and the other part is opposites. These are called conjugates. And when there's conjugates, you can take the shortcut I taught you. The outside and the inside will actually cancel off, so you actually don't have to do them. Before I go on, I'm going to show you that they cancel off. In the outside, you get 15 root 2, and the inside you get minus 15 root 2, so we're not even going to bother to write those down. And I call this affectionately my Florida shortcut. So when you're multiplying conjugates, just do first and last, and I've got them written here, 25 and negative 9 root 4, and simplify. You'll get a whole number answer. You'll get an integer answer. You might get a negative, but here's just 7. So the radicals melts off when you do this. You should never have a square root or involved in these type of problems when you're done. Okay, so the last one I'm going to cover with you right now is number 23, and number 23 has a binomial, I'll highlight it, on the bottom, with a radical. And to rationalize the denominator on these types, you're going to, first of all, notice that there's a binomial on the bottom. And the way to undo that problem with the square root on the bottom is to multiply by the conjugate of the bottom. So you see that I had 2 plus 6 root 2, and now I'm multiplying both top and bottom by the conjugate value to minus 6 root 2. Now what that does for us on the bottom is we only have to do first and last, but up top you have to multiply all 4 of the terms, first, last, outer, and inner, and that's what I've done there. And then simplify, and simplify again. And in this case, you can simplify yet once more. So I'll show you that. You can't cancel there. That's not allowed. Can't cancel there. That's not allowed. But if you can cancel all 3 of them, 20, 26, and 68. In this case, you can divide them all by 2. So this will become 10. That'll be a 13. And this will become negative 34. So I'm just going to clean up the answer here, and we'll be done with this problem. 10 minus 13 root 2 over negative 34. And that does it for all the way through problem 23.